So today we are going to go over how to solve an integral using u substitution. So say you have a problem like y equals the integral of 0 to 3 of x over x squared plus 1 dx. Now, because this is an integral function with this in it, it's actually quite hard to solve. And so we want to make it easier for you. So we're going to use u substitution. And what that does is it's going to simplify it and make it easier to solve. So you're going to have u equal to a part of your function. For this, we are going to use x squared plus 1. And you're going to actually take the derivative of this u so that you can get it in a simpler form. And that's going to be 2x, because the derivative of x squared plus 1 is just 2x. And let's see, du dx. And we are going to put this in terms of just du. So it's going to equal 2x dx. And this is quite close to what we have in this function over here, but we need to make it the same so we can actually substitute it in. And all you have to do for that is just divide 2 onto the other side. So it's going to be du over 2 equals x dx. And that's exactly what we have over here. So we're actually just going to go plug that back into the problem now. So you're going to have the integral, and you're actually going to leave off the limits for a moment. We will come back to those in a second, but because this is a problem in terms of u and not in terms of x now, because we're changing it, the limits have changed also. So we'll come back to that in a minute. But for the bottom, you're going to have just u, because x squared plus 1 is u, so that'll be your bottom limit. And for the top, you have x dx, and that's equal to our du over 2. And so you just plug that in, du over 2u. And so this is our modified function. And we're actually going to simplify it a little bit more. So you're going to have the integral of 1/2 du over u. And at this point, we're actually going to plug the limits back in. But because they have changed, like I said earlier, from using x, and now we're using u, we're going to have to plug that in using this equation. So your u, and you're going to plug in your bottom limit, so 0 squared plus 1, that's just 1, so we're going to write that over here. And then for your top limit, which is 3, you plug that in also, and you're going to get 10. And so your new modified function is the integral from 1 to 10 of 1/2 du over u. And we can actually simplify this even more by taking this 1/2 and putting it out in front of the integral. It doesn't really have a bearing on the problem, and it'll actually just make it easier to solve because you won't have to worry about it for a bit. So we're going to put that out front, and you have your integral from 1 to 10 du over u, or just 1 over u du. And this should look familiar. Usually it's in terms of x, and when you take the integral of 1 over x, you're going to get ln x. And so the same thing happens with u. 1 over u turns into ln u. So now we have ln u, and we need to evaluate it from 1 to 10, so we put that at the end. And you can't forget that 1/2, because that's going to be multiplied by everything at the end. And so what you're going to do now is you're going to plug in your evaluation points. So you're going to have ln 10 minus ln 1, and that's all multiplied by 1/2. And the thing about ln 1 is that it just turns into 0. So you can just cross it out of the problem. All you have is ln 10 times 1/2. And that's actually your finished product. You're done with the problem.